Fault Finding Lesson 1 Safe Systems of Work. In each slide, you will find a small video. Read the text, watch the video, and then on the following slide, answer the questions using your own words. You'll need to pause the video in order to answer the questions before you move on. Through this lesson, you will understand some common terms used in fault finding. We will discuss the dangers associated with fault diagnosis and list the safe isolation procedure. Finally, we'll consider some safe systems of work that are used in industry. When looking for faults, if a safe system of work is not used, far too much can go wrong. This method works best for the safety of yourself, others around you, and leads to a much more efficient diagnosis. A safe system of work would include primarily a risk assessment and a method statement, but it might also include a permit to work. If the safe system of work is not followed, this can lead to accidents happening caused by people who are not aware of the risks or how to approach their work. The law only expects people, who include employers, the self-employed, employees, designers, manufacturers, suppliers, and importers, to look at the risks and implement measures to reduce those risks. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. Throughout this course, you'll hear a number of phrases that you'll need to understand. These include the duty holder, who is the person in control of the danger, the competent person, which used to be known as the trained or experienced person, is now called the skilled person, or if they're not able to perceive risks, they're known as the instructed person, and statutory instruments, which are acts of parliament or laws that give powers to other bodies or organisations to act on behalf of the government. For example, the HSE are given the powers to enforce the Health and Safety at Work Act. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. Statutory regulations are defined by a formal law. Non-statutory regulations are considered to be common law. These regulations are designed to help you to be able to comply with the statutory regulations, but they're not law themselves. These non-statutory regulations are produced by the statutory instruments. We previously mentioned the HSE, but as electricians, the IET, that is the Institute of Engineering and Technology, produced the BS 7671 regulations for use in electrical design. These non-statutory regulations help people interpret and understand what the law says in the Electricity at Work Act, among other things. To help people comply with the law, they also give technical advice. In short, following non-statutory regulations is not compulsory, but following the guidance will normally be enough to comply with the law. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. So the big problem with electricity is that you can't see it. In fact, a dead cable will look exactly the same as a live cable, but it can cause damage to property, serious injury to humans and animals, and it can even kill. Only a good knowledge of electrical systems and the use of the correct test instruments will prove the cable to be live or dead. The regulations produced by the IET and BS 7671 give us advice on how to protect from electric shock, high voltages, high temperatures, under voltage, over voltages, electromagnetic disturbances, power supply interruptions, and arcing and burning. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. The Electricity at Work Regulations 1989 are statutory regulations that can be used in a court of law. Regulation 4.3 of the Electricity at Work Regulations states that every work activity, including operation, use, and maintenance of a system, and work near a system, shall be carried out in such a manner as to not give rise, so far as reasonably practicable, to danger. In simple terms, this means that in all your work, you should not create a danger to others. The majority of electrical accidents happen when people working with electrical systems believe the supply is dead when it is not. There are times when a system is known to be live, but the duty holder does not have adequate training, equipment, or may even be neglecting certain responsibilities. The term reasonably practicable is not a get-out clause, as some would insist. The term is only used as there are rare situations where it may be required to work with live equipment. If this is the case, every reasonable precaution should be put in place and should be highlighted in a risk assessment. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. The Electricity at Work regulations number 13 and 14 cover dead and live working. The preferred method is always going to be dead working. In Regulation 13, which covers dead working, it states that precautions shall be taken to prevent items made dead from becoming live. This essentially means that we should always safely isolate a circuit before beginning work. In Regulation 14, where we're talking about working near live conductors, it states that live work should not happen unless it is, first of all, unreasonable to be made dead. Secondly, it's reasonable to be working near live conductors. And finally, that suitable precautions have been taken to prevent injury. In simple terms, don't work live unless you have reasonable precautions in place. Jobs need to be planned so that they are carried out as required by this regulation. Safe isolation is the method recommended in each case. Fault diagnosis particularly is best done when the circuit is isolated. Some electricians may find that working live is faster, and by practicing this method they pass on the bad habit to newer, less experienced electricians. In this case, they are being exposed to a dangerous situation and they are going against the law. Before starting work on isolated equipment, checks should be made to ensure that each circuit is dead. We will cover this in the next section as we move on. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. Since the safe isolation procedure is vital for the safety of yourself and others, you will be repeatedly tested on this through your training and beyond. The procedure can appear different depending on who you ask, but in general, each procedure will contain the following elements. Firstly, you're to locate the correct source for supply to the section needing isolation. This could be an individual circuit, or it could be an entire building. It could be anything in between. Secondly, to inform anyone in the area who may be affected by the removal of the supply. As an example, if you were to turn the lights off in a room with no windows, you'd be creating a hazard for anyone in that room. Thirdly, you're to confirm that the device used for isolation is suitable and may be secured effectively. This means that you must be able to lock the device off. If you can't lock off the device, then you're not isolating the circuit, you're switching the circuit. Fourth, you're to power down loads if the isolator is not suitable for on-load switching. If any items are left on or consuming current while the isolator is switched, you get arcing or electrical contact across the electrical contacts. This could cause damage to the isolator. Fifth, you disconnect using the located isolator that we've just found. Essentially, this is the switch off stage. Sixth, you're to secure the off position. Secure the device in the off position and keep the key in your pocket. Then you're to post warning signs. This is the lock off section. Step 7, you're to select an approved voltage indicator to GS38 and confirm its operation. GS38 is a set of regulations for test instruments, highlighting checks that must be made on leads and casing of the test instrument. Additionally, the tester must be tested on a proving unit. Using the voltage indicator, step 8, you to confirm the isolation, checking all combinations, probe into the low voltage side first. In a single phase system, you would take the first probe to the earth and neutral, then the earth and live, and then the live and neutral. For a three-phase system, there's a longer process. You must test between all live conductors. Beginning with the earth, you probe to the earth and neutral, the earth and live, or L1, earth and L2, earth and L3. Secondly, you probe neutral to L1, neutral to L2, neutral to L3. Finally, between the live conductors, L1 to L2, L1 to L3, and L2 to L3. There should be 10 steps through the three-phase process. It's important to start with the low voltage terminal first, since the circuit at this point is not proven to be dead. If it is still live at any point, then the lead not placed on the live terminal may also have a voltage and could result in the shock to yourself or someone else. Finally, to reprove the voltage indicator on a known source, this is usually going to be the same proving unit that you used at the start. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. As we've previously discussed, there'll likely be times when you may feel pressure to work live. If this is the case, you'll do well to remember the risks that you'd be taking. For yourself carrying out the work, you'd risk electric shock or burns. For the occupiers of the building, you'd be responsible if they came into contact with electrical parts when the basic protection is removed. For customers or clients, there's also the risk of shock or burns, but additionally, they've got the worry of damage to equipment or property. You'd be liable for that as well. Remember the requirements of Regulation 4.3 and Electricity at Work regulations. Work on or near electrical systems shall be carried out in such a manner as to not give rise, so far as reasonably practicable, to danger. It'd be wise to follow a safe system of work, including a risk assessment, method statement, and a permit to work. This is sometimes abbreviated to RAMS. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. A risk assessment is intended to help the duty holder identify and minimize all potential risks. A risk assessment is made up of 5 parts, but it can be simplified to just 3. First thing to do is to identify any hazard that may arise as part of the work activity. Second is to identify who may be hurt and how. If nobody can be hurt by the identified hazard, then is it really a hazard? Third is to consider the precautions that you can put in place to reduce the hazard or remove the risk entirely. The fourth step is to record the information. This should be done as part of the formal exercise. And then fifth, after a short period of time, the risk assessment should be reviewed to ensure that it is adequate for the work activity. Any adjustments should be made at this point. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. A method statement is a plan of how a work activity will be carried out. It'll include things like who is authorized to do the work and how will they access the test area. Also, who should or should not be allowed to enter the test area. It'll also include arrangements for isolation, what PPE, tools and equipment are required, additional protection including barriers and notices. Also, how problems that you come across will be reported and what action will be taken. This should also, like the risk assessment, be reviewed in case of changes that may happen. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. A permit to work may be required by an organisation so that you can inform them of your work activities that may affect their work activities. The permit to work should state the name of the person authorised to complete the work activity they are assigned to do, and which items of equipment will have to be isolated. It will also include where the equipment is to be isolated and where warning notices will be posted. Additionally, it will identify any other hazards that may be affected by other work being carried out at the same time. There is a difference between risk assessments, method statements, and permit to work. In simple terms, a risk assessment is for the duty holder to identify potential harm and remove it. The method statement is used to plan activities in the most efficient way. And the permit to work is sometimes required to inform the company of arrangements that may affect their work activities. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. For this task, you must complete a risk assessment. You are required to install lights using steel conduit and single insulated cables in a lift shaft supplied from a consumer unit in a small room at the top of the work area.